Okay, so before we spoke about coterminal angles, and we're going to continue a little bit more about this. Coterminal angles are angles that have the same initial side and the same terminal side when they are in standard position. And we discussed some of these numbers before as degrees. Now, because we have a different measure, we now kind of start to understand the different measure, which is radians. We also can do the equivalent with radians. So you have an angle in radians. How do you get coterminal angles in radians? So you don't need to convert to degrees, get the number, and convert back to radians to present the answer. That's a lot of work. Instead, we have the same understanding. So let me just refresh a little bit what it is in degrees, and we're going to actually work in radians. So let me give an example right here. Let's say I have an angle alpha, which is 55 degrees, and I want a coterminal angle with 55 degrees. Coterminal means it's going to have the same terminal side. We know already that an angle in standard position means they always start from the same place. So they always start from here. Because 55 degrees is positive, it means I would rotate to the left, like against the clock hand, up to a 55 degrees somewhere right here. Okay, I'm not being precise, but it will be in the first quadrant. So this is what I think it is, my 55 degrees. Now I want another angle that starts the same way and ends in the same position, but it's not 55. So meaning if I add a full rotation from here and come back to the same position, I get the same, right? It's basically just adding 360. So if I take 55 degrees and add 360, so I have what? 415, yes. Right? So 415 and 55 degrees, they are coterminal just because they have the same initial side and the same terminal side position, but the angle themselves are not the same, right? For example, the 415 degrees means you start here, and I'm gonna do a full circle and a little bit more in this position here. So they're gonna have the same initial side and the same terminal side, but the angles are not the same. Okay, so that's how we get in degrees, right? You either add or subtract 360 to get a variety of coterminal angles. Now, if you have your angles in radians, that's the same idea. Instead of adding 360, we're going to actually add 2 pi, because 2 pi is the same as 360. But I needed to do in the same type of units that I have in the original angle. Example number 6 is already solved, right? So it's taking the angle pi over 3 and adding the equivalent in radians of 360 and subtract the equivalent of 360 as well. So if you add 1 time 360, but in radians, you're going to get another coterminal angle. If you subtract 2 pi, which is the same as subtracting 360, you get an angle also in radians. So that's the idea. So because of the angle is given in radians, all you need to do is to add 2 pi or subtract 2 pi multiple times. Sometimes it depends how many of the angles you need, but this should give you the answer already in radian without actually having to convert between the units. So we're going to draw the angle in standard position and find an angle between 0 and 2 pi. One thing you need to notice that 12 divided by 5 is 2.4, right? So what I'm saying is that at this point right here, this angle is beyond the 2 pi. This is, if you divide, this is 2.4 pi, so beyond 2 pi. So you want to bring down to something less than 2 pi. So you subtract 2 pi from what you have, get the answer, reduce to the fraction if possible, and that will be an angle between 0 and 2 pi. The angle is not right now between 0 and 2 pi. So if I have 12 pi over 5, I'm going to subtract 1 time 2 pi. So 1 time the value of 2 pi. Okay, I'm subtract just once. With this once, I should bring down to something between 0 and 2 pi. Now, these are fractions. I put the 1 there, but there's no need to put that to 1. It's just to say I'm only doing this one time. Sometimes you have to do more than one time. I saw this with degrees. So what I want you to notice is that this is also a fraction with denominator 1. And because radians, most likely you have only fractions all the time, you just need to reduce. Think that to add or subtract fractions, all you need is the same denominator. The LCD here should be 5. Meaning, if I multiply the second fraction top and bottom by 5, I get that same denominator of 5, right? So now both fractions will have 5. But the numerator is actually the operation I want to do. So here I have 10 pi, so it's minus 10 pi. And the same denominator on the bottom. So I keep the denominator, subtract the top of the fractions. So 12 pi minus 10 pi is 2 pi. So 2 pi over 5 is the coterminal angle with 12 pi over 5. And that angle is also between 0 and 2. 5, right? So notice that this is a number between 0 and 2, so it is where I want. So 12 pi over 5 and 2 pi over 5 are coterminal.